This example is finding the intercepts and rate of change from a graph using an actual real-world example. Scientists are measuring a distant planet's temperature. The graph shows the temperature versus the height above the planet's surface. So I have a graph here, and across the x-axis you'll see it has height in kilometers, and the y-axis is temperature in Celsius. My first question is A, what is the temperature at 0 kilometers? So I'm going to look over here at 0 kilometers, which is the height. This is actually going to be the y-axis. So I'm going to go up and see what is the temperature at 0 kilometers. The temperature would be 40 degrees Celsius. Remember, you should always label your answers when they're in a context. B, choose the statement that best describes how the height and temperature are related. Then fill in the blank. So I have two options here. The first one is as the height increases, so as our height gets larger and larger, the temperature decreases. So as I'm looking here, as my height, my numbers are going up, what's happening to the y values? Well, the y values are going down. So as the height increases, the temperature decreases. This is a true statement. The other one says as the height increases, the temperature increases. Well, that would be a graph more like this, with a positive slope. The rate the temperature decreases is how many degrees Celsius per kilometer. This is asking us to find the slope, and as you recall, slope is rise over run, or we could also think of that as change in y over change in x. So change in y over change in x. So I can look at from start to finish. That would be perfectly fine. And my rise is 40. And the run is 4. So 40 divided by 4, which is 10. So the rate the temperature decreases is 10 degrees Celsius per kilometer. Part C says write a function f to represent this situation. So it's asking me to write an equation for this line. It's asking me to name it f, so I will call it f of x. This is a linear function, so we're going to follow the y equals mx plus b, the slope-intercept form for this. We already discovered our slope was 10 degrees Celsius per kilometer. It is a negative slope. Notice that our temperature is decreasing, so that's going to be negative 10. X is our input, which is height, and then plus b. b, as you recall, is your y-intercept, so it would be plus 40. So negative 10x plus 40 is the equation for this line.